Okay, let's look at question number 5 of the 2021 AP Calculus AB exam. And so this one looks like a differential equation. No, it's not. It's an implicit differentiation. Okay, cool. This one's a kind of a throwback question. I haven't seen one of these in a while. I haven't read any of these problems yet, so I'm kind of processing them in real time here. So we have a function f. They give you the equation is 2y minus 6 is equal to y times the sine of x. And they ask you to show that dy dx. So they are giving you the answer for part A. They are giving you what the derivative is. We just have to find the answer. So that's kind of nice. It's an implicit differentiation. The derivative of 2y is going to be 2 dy dx. 6 will zero out. We have a product rule over here. So the derivative of y times sine x plus y times the derivative of sine x. And we need to solve for dy dx. And when you're proving a problem, when they give you the answer, you don't want to skip steps. So I'm going to very meticulously solve this. I'm going to subtract the dy dx term. And we will have y cosine x I'm double checking. Something doesn't look right here because I'm expecting the numerator. Oh, never mind. This is okay. I copied the problem wrong. That's why it's not working out. Okay, make sure you do. Okay, so that's 2y squared, not 2y. I just copied it wrong. All right, now it's looking better. Whoops. Okay, so make that a 4y. Make this a 4y. Okay, cool. Now I'm going to factor out the dy dx. All right, so this is being really nice. So I'm going to factor out the dy dx. That leaves you with 4y minus sine x is equal to y cosine x. And then we'll divide by 4y minus sine x, and that gives you exactly what they said you should get. Y cosine x over 4y minus sine of x. And there is your answer for part A. All right. Number B, write an equation. Oh my God, an equation of a line tangent. Could they be any nicer? So we need a point, which they give you is 0 root 3. We need a slope. And this is so nice because even if you could not do part A, they gave you the derivative. Just use the derivative they gave you. So my slope is going to be y cosine x over 4y minus sine x. So that'll be root 3 times the cosine of 0 over 4 times root 3 minus the sine of 0. And they don't ask you to use this tangent line or do anything with it. If you want to, you can write your answer like this. Y minus square root of 3 is that. Square root of 3 cosine 0. Boy, my cosine's sloppy there. 4 root 3 minus sine of 0 times x minus 0, and you can stop there. However, this does clean up kind of nicely. That slope ends up being 1/4. And so it does clean up quite nicely to y minus root 3 equals 1/4 of x minus 0. I prefer to leave my answers in point slope form. You could write that very easily in slope intercept form if you so desire. Let's move on to part C. Let's see, so from 0 to pi and y's that are positive, find the coordinates of the point where the line tangent to the curve is horizontal. So if you want a horizontal tangent, that means you want the slope to be 0. So this question is C. So I want the slope. I need dy dx, which is y cosine x all over 4y minus sine x. I need that to equal 0, which is going to happen when the numerator is equal to 0. And they do say only on the interval 0 to pi and for y's specifically greater than 0. So I want to say y is equal to 0 and x equals pi over 2. Those are the two places to make my numerator 0. However, they do specifically say y greater than 0, not greater than or equal to. So we toss this one. We only have the one at x equals pi over 2. I'm going to plug pi over 2 into the denominator really quick. 4 times pi over 2 minus sine of pi over 2 will not give me 0. I just wanted to make sure my bottom was not 0 as well. They do say find the coordinates, not just the x. So now I need to find the y associated with that. So I go back to my original equation up here. 2y squared minus 6 is equal to y times the sine of pi over 2. Sine of pi over 2 is 1, so that turns into 2y squared minus y minus 6, and we will solve this by factoring. 2y, y, 2, 3, positive, negative. We get y's are negative 3/2, and y is 2. Make sure I factor that correctly. Good. Again, remember that we are answering only for positive values of y, so we throw that one out. And the only point where this happens is at the coordinates pi over 2, 2, and there is my answer, and we are ready to move on to part D. So let's look at part D. Okay. Determine whether f has a relative min-max or neither at the point found in part C. Okay. I think we're going to have to find the second derivative. We already have established that at this point, pi over 2, anytime you see relative max, min, or neither, you want to first establish critical numbers. Well, we got the point by setting the derivative equal to 0. So we already know the value of the derivative at this point from part C is equal to 0. We already know that. So now the question is that a max, min, or neither? And I would like to do first derivative analysis. However, my first derivative is a function of x and y, which can create some problems. So we're going to find the second derivative, and we're going to measure the concavity. We already know the slope is 0. If we can show that the function is either concave up or concave down, we can conclude that we have a max or a min. So now I've got to find the second derivative of this thing right here. So I'm going to box that so I can see it easily. We have to do a quotient rule implicitly. So my second derivative will be low 4y minus sine x d high. Oh gosh, the product rule is dy dx times cosine x. And don't forget, we are impliciting this. So dy dx cosine x plus y times the derivative of cosine, which is negative sine. Holy cow, that's all low d high minus high d low. I'm going to have to move this down here. I don't have room for all this. Okay, so we have low d high minus high d low is going to be 4 dy dx minus the derivative of sine x all over 4y minus sine x squared. Okay, now I want to evaluate my second derivative at the point pi over 2, 2, and all I have to do is determine positive or negative. And the good thing is that at the point pi over 2, 2, dy dx is equal to 0. So anything with dy dx, we can replace that with a 0. I still need to plug in pi over 2 for my x's and 2 for my y's to determine whether we have a positive or a negative. And so I would have 4 times 2 is 8, minus the sine of pi over 2 is 1. I have 0 times cosine x, I'm not worried about that. Y is 2, sine of pi over 2 will be 1, so that's going to be a negative 2 for this piece. Minus cosine of pi over 2 is 0, and for that, after that, I don't care about the rest. That's actually going to be 0 anyway. All over. My denominator, 4 times 2 is 8, minus sine of pi over 2 is 1 squared. So I have 7 times negative 2 is negative 14 over a positive. That will result in a negative second derivative. Therefore, we are concave down. We are concave down. Therefore, there is a max at the point 2 pi over 2 comma 2 by the second derivative test. And there is question number 5. That leaves us with one more. So how long did that one take? That was 10 minutes. That's about where I'm averaging on these.